Let me share my screen. My screen is able to. Are you able to see my screen now? Say yes or no, someone. Someone unmute and say. Are you able to see my screen?
Yes, sir.
Okay, okay.
Yes, sir. But chat box is not visible, sir.
Okay, no issues, no issues. Okay, there is some issues with the chat box, so no worries. Okay, so let's get it started. So what we are discussing? We are discussing about abstraction. If you're not able to see the chat box, you can go back and you can get this page. Especially you can get this Teams tab. Not in the same Teams icon. Okay, not here. Just click on the Teams icon. Okay, you usually get this page. Here you can type. I'm not sure why the chat box is not visible for you. For me, it is visible. Venkatesh, are you able to type anything in the chat box? Venkatesh is able to type. Yeah. So go back and see. Don't wait. Don't wait here. Go back and see. You will be able to type it here. Okay. Okay. Let's get it started. So we are discussing about abstract classes in Java. Today we will get the complete picture. So please always remember these points for the abstract classes. Okay. An abstract class must be declared with the abstract keyword. Okay. And abstract class can have abstract methods as well as non-abstract or concrete method. And you cannot create object for the abstract classes. You can have constructors, you can have final methods, you can also have static methods, you can also have properties or member variables. You can have variables in the abstract classes. But only one drawback with the abstract class is that you cannot instantiate or you cannot create an object. Look at this, focus here. You cannot create an object for the abstract class. This is the only one drawback that we have. Okay. Apart from this, everything would remain same. Okay. Let us take one example today, and we will cover all these points together. Okay, so that you people will not get forget. Okay. So let me open Eclipse. So I want to take two classes. I have taken class A and I have taken class B. Okay, two classes. These two classes are, when I ask you what kind of classes are these, you should say these two classes are concrete classes, not ordinary Java classes. Right? From onwards, try to get used to the concrete keyword, concrete. Okay? So when you have a class without abstract keyword, when the class is ordinary, okay, it is called as concrete. Okay? So these two classes are concrete class. Of course, this is also a concrete class, no issues. But this is a main class. Specifically, this class is a main class because of the main method. Okay, now see what I am doing. I am making a relationship between class B and class A. Class B is extended to class A. I want to take a simple method, void m1, okay, and system.out.println. Okay, whenever this method is invoked, so, okay, I want to print a message like B class m1 method. Okay, and in the class A, I am placing the same method. This time I want to print a message like A class m1 method. Okay, when you see the same methods in the parent class as well as child class, what is the thing that is coming into the mind? Overriding is the thing that has to be in your mind, because only when you find any methods, okay, or when you find similar methods in parent class as well as in the child class, we can call this method as, we can call the child class method as overriding method, and you can call this method as what? Overridden method. Now you see what I am trying to do here is, okay, let me increase the font size. Okay, now you see, So in the driver class, I want to create an object a obj equal to new b, upcasting. Parent class reference and the object is created for the child class. Okay. See, I'm trying to execute the M1 method. Okay, the moment I try to execute the M1 method, especially in the overriding concept, always remember that the RHS side, the objects, the object has been created for class B. So the method inside the class B will get priority. So M1 output should be B class M1 method. Okay, these things are, we have already discussed these things. Okay, B class M1 method. See, so B class M1 method, but we have a parent class. We have a parent class. So this body has nothing. This body is become, the body of this M1 method has become useless, right? At any point of time, when I call M1 method by creating the object in this way, okay, by using this object reference, whenever I try to call M1 method, definitely this M1 method will get executed. Yes or no? This M1 method gets executed. Okay, but this body, don't you think that the body of the M1 method in the parent class becomes useless? It's always useless. Even if I call this M1 many number of times, obj.m1, obj.m1. Okay, so when I use this object reference, okay, object is created for the child class, but the reference type is of parent. Okay, child class object, reference type is of parent. Okay, by using this reference variable, you can call M1 method any number of times. You can call 100 times or you can call 200 times. Every time this body will get executed, not this one, yes or no? Not this one. So when you encounter this kind of situation, when you encounter, okay, the body of the M1 method in the parent class is not even getting a chance to get executed. Okay, let me run this code. So every time B class M1 method is getting executed. That is what the Java is. Is what the overriding concept is. Do you think that this body is useless? So one line, no issues. What if you have 1000 number of lines? What if we have 1000 number of lines? Those 1000 number of lines in the parent class method becomes useless. If you find any kind of situation, okay, what is highly recommended? Remove this body. Just use the terminate statement. Use this terminator. Okay, and use abstract keyword. Okay, so every time, okay, again, even though if you execute M1 method over and over again, this body gets executed, not this one, because it is previously the body itself becomes useless. It looks useless. Okay, you cannot execute this by the way the object is being created. Yes or no? You cannot execute this. So what I'm trying to do, I'm going to remove body. So removing the body itself is not okay. Whenever there is a method with only the declaration, it's mandatory to use the abstract keyword. Okay, it is mandatory to use the abstract keyword. And if any class has an abstract method, okay, it is mandatory to use the abstract keyword so that the method has become what? Abstract method. Okay, if any class is having an abstract method, the class would also be what? The abstract class. Right, now there is no error. See, even if I try to run this again, okay, let me run this once again, we are getting the same output. Making sense? So when you have any method, with just the declaration without any body, okay, just use the abstract keyword. Okay, when you use the abstract keyword, the method becomes abstract method. Okay, in a particular Java class, if there is at least one abstract method, the class should also be what? The class should also be abstract class. As simple as that. First takeaway. So this is the first takeaway. Okay, the second takeaway, an abstract class can have abstract methods as well as non-abstract methods. For example, I can take a different method like void m2. Okay, void m2 system.out.println a class m2 method. a class m2 method. Okay, by using the same reference variable, obj dot m2, I can access this method. How I am able to access this method? Usually what happens, obj is of what type? A type. Okay, firstly the object is being created for p. Okay, if there are any similar methods, so this method is similar and this method is also similar, by the method declaration they are similar in nature. Okay, this is a specific method. Definitely this method is going to get chance. Okay, if I run this code, okay, a class m2 method is getting executed. Okay, first this m2 method will directly it is not even the overriding concept. So the obj is of a type. Directly it will jump into a and will try to look for the m2 method. The logic inside the m2 method gets executed. So I can conclude that an abstract class, second conclusion, an abstract class can have abstract methods as well as non-abstract methods. Now the third conclusion is, can I have variables in the abstract class? Can I have variables in the abstract class? The problem here is you cannot create object for the abstract class. Can we create object for the abstract class? Okay, I cannot create object. Okay, when the class is abstract, okay, the class A is abstract in nature. When class A is abstract in nature, you are not supposed to create an object for the respective class. New keyword is not possible for the abstract class. When you do that, you definitely will get an error. So what it says, cannot instantiate the tab. I cannot create an object for this. So this is illegal. Okay. Object creation is not possible. Not possible. So there should be a question in your mind. So when you are not able to create an object for the abstract class, when this is not possible, how you can access any variables that are declared in the abstract class? For example, in the abstract class, I want to declare a variable like string a equal to Java. Okay, and in the child class, I want to declare a variable like string b equal to Python. String a equal to Java, or else let us do this. String b, just declaration I am doing. String a, I am just doing the declaration. Okay, if I give this code to the compiler, if this code has been submitted to the compiler, what the compiler is going to do? Guys, what the compiler is going to do? The interesting part will happen. Okay, let me remove all this. We will have only one. Let me remove all this. Okay, when you submit this code to the compiler, for that I need to use the paint screen. Yes. Okay, when this code has been submitted to the compiler, what compiler is going to do? It will check each and every class. Okay, abstract class is not extending to it as we are not extending this abstract class to any other class. By default, compiler will extend this to object class. First thing. Okay, and it will try to find the variable. Okay, variable looks fine. Nextly, what it will do, okay, it will try to find, is there any constructor declared by the developer? Okay, there is no constructor declared by the developer or the programmer. So the compiler is going to define a default constructor. Yes or no? Compiler will definitely do what? It will define a default constructor. Okay, a default constructor will be placed by the compiler, and after that, inside that, it is going to place the super keyword. Okay, compiler's optimization. Compiler will optimize the code. Compiler will do these changes. That's why I have written this in red. Okay. After this, it will try to find the method. Method looks good. Okay, and class B is extended into class A. No changes required. There is a property, or we can call it as variable. No changes is required. And the class B has no constructor. So compiler will place a default constructor even inside the class B. Okay, so placing the default constructor is not fine, and also it will place the super keyword. right? So after this m1 method is also looking good. Okay, and there is a driver class. Driver class is not extended to another class. Now compiler will do what? Compiler will extend this to object class. Extends to object class. Okay. After this, it will go inside the class and it will try to find is there any constructor defined by the developer or the programmer. No, there is no constructor defined by the programmer. Okay. So the compiler will do what? It is going to define the default constructor by the name of what? Driver. Driver. Okay. So along with this, we'll use super keyword. Okay. So this is the compiler's optimization. These many things will be done by the compiler. The compiler is doing a very great job. If you forgot to define any constructor, it is going to define its own constructor, the default constructor. Okay. If you're not extending any class to, I mean, if you're not keeping a class in a relationship, okay, the internally compiler is going to do this for you. Every class extends to object class if it is not extending to any other class. Since this B class is extended to A class, no issues, it will not touch this. Other classes are not extended in the class. So these are the changes that is being done by the compiler. Okay, now in the main class, okay, let us try to focus here. Okay, see here we have the variable. Okay, I have already said whenever you create an object, so just try to go back and see the object creation process. When you're creating an object for a particular class, okay, this object is going to accommodate the respective variables, yes or no? If I create object for class B, okay, it is going to, this object is going to accommodate space for the respective properties inside the class B. How many properties we have inside the class B? There is only one property, string B. Okay, so default value will be allocated. This is what we have discussed, right? String B equal to null. Okay, let us understand this in a different way. Okay, let me remove this. Okay, for example, a obj equal to new a. Okay, we are creating object for what? New a. A is what class? A is abstract class. Okay, this is not possible. You cannot do this because object cannot be created for what? Object cannot be created for the abstract class. Okay, if object cannot be created for the abstract class, who will perform the declaration to these variables in the abstract class? Who will do this? Who will complete performing the declaration or assigning the values to these variables? Usually all the variables inside a particular class will be what? The values will be assigned by the constructor. You can initialize the values by using the constructor, but the constructor will be invoked. How? Constructor will be invoked when you are creating an object. But if you're not able to create object, how you can invoke this constructor? How you can call this constructor? That is the question. So what usually happens behind the scenes? This is not possible, boss, but you can do this now. You can do what? A obj equal to new b. This way you can create the object for the child class and you can create the parent class reference here. This is possible. Now what I am doing? I am creating an object for the child class. Yes or no? New b. New b. What is the reference variable? Reference variable is obj. The reference variable is what? Obj. Now see what is happening. Now B class constructor will be called. Yes or no? B class constructor is going to be called. Suppose B class constructor called. So the control will try to find the B class constructor. B class constructor is here. Just arrived here. Just exactly arrived here. Right? So once it has arrived here, okay, what is the first keyword inside the B class constructor? Super call. Super means what? Super means the parent class constructor. So the control has to jump from here to the parent class constructor, A class constructor. Okay, let me write the control flow. The control flow started from here, guys. This one. Okay, from 1, okay, since it is a constructor call, object is created, it means constructor needs to be called. Okay, the control will jump here. Okay, this is 2. This 2. Okay, the second, from here it is a super constructor call. It will jump to the superclass constructor. Okay, the control has come here. This 3. Right? So before even executing this constructor, okay, we have already discussed, okay, whenever the constructor is getting executed, before executing the constructor, the respective class's instance variable needs to get executed. Have we discussed this in the object creation process? Not in the object creation process. We have discussed this in the instance variables and instance methods and instance blocks. Okay, instance variables are executed before executing the respective class constructor. So before executing this constructor, the constructor has to execute this. What is this? Fourth one, the respective class reference variable. Control will come here, 4. Right? What happens internally? Okay, this obj belongs to B class. I mean, object is created B class, but this B class is extending to A class. Okay, so the controllers come here to execute the constructor of A class. Okay, before executing this constructor, it has to assign the variable of the A class. Okay, what is the variable name here? A. Okay, so in the A equal to null value will be assigned. Okay, then after this, okay, after this the control will go back to the place it was called 4-3, from 3 to 2. Before even completing this block, okay, even though this is a constructor, right, it has to execute the respective class reference variable, then the constructor call should be completed. Okay, B class reference variable is what? B, right? So since declaration is just done, initialization is pending, right? So B equal to null, right? Then this call will be completed. From here it will come back to this place, the same place. Okay, there are no instructions to get executed. The main thread will get destroyed. So what are the values that we have? A equal to null we have, and B equal to null. Okay. Do you think we are going to get the same value? Let us try to check that. Okay. A obj equal to new B. Okay. System.out.println obj.a should be null, right? S by S4. obj.b should also be what? Should also be what is happening here? Yes. Okay, obj.a is null. So this B, okay, we are able to get access with, because this is the parent class reference. We are using the parent class reference, and the object is created for the child class. Whenever you are dealing with the variables, only visibility will be there for the parent class. Okay, when I do the object creation like this, B obj equal to new B. Okay, by this I can able to access both obj.a, both obj.b. Okay, now the output has to be what? Null. So this is way 1. Okay, way 2 a obj equal to new a obj1 equal to new b obj1 dot a. Sorry, system dot out dot on obj1 dot a. Null. Okay. With the abstract class, we will be able to create object in 2 ways. One is child to child, next one is parent to child. Remember this. Child to child, parent to child. With the abstract class, this is not possible. Way 3. What is a way 3? A obj2 equal to new A. You cannot create object by using the parent to parent class. You will get an error. It is not possible. This is not possible. Only there are two ways of creating an object. One is parent child to child. Second one is parent to child. By using child to child, you can access the child level variable as well as the parent level variable. By using parent to child, you can access only the parent class reference variable. Okay, so when I use this, this is what we have used here. When I use this option, okay, I will be able to access. Okay, when I use system dot out dot println, okay, when I try to get access to obj.a, even though the B class object, even though the object is created for the class B, but we are performing a restriction. What restriction? We are performing a restriction like the B class object is assigned to the A class reference variable. B class object is assigned to the A class reference variable. If this is the restriction, only you will be able to get access to the A class reference variable. Only this value becomes visible. What is that value? Only this value becomes visible. But when you create an object for the child to child, the obj equal to new B. If this is the case, you can get access to the B class variable as well as A class variable. Okay, there are three ways I'm trying to say. So whenever you're dealing with an abstract class, you should remember, object creation is possible by three ways, but for the abstract class, you can either create object like this, child to child, or you can create object like parent to child. Okay, as simple as that. We will see a few more examples. Let me place in the notes. So we got to know we have completed this thing. We have also completed. You cannot create object for the abstract class. This is also fine. You can have constructors. Just now I have completed. You can also have the final methods also. Okay. Now you see, sometimes you will face a situation. Okay. So let me remove all this. Okay, I have, let me take three abstract methods. Okay, this is M1 and this is M2 and this is M3. So I have three abstract methods by the name of M1, M2, M3. Okay, rule number, the actual rule is satisfied. What is that? Abstract method can be placed only in the abstract class. Okay, this rule is satisfied. But some other class is extending to class A. Class B is extending to class A. But this class A is of abstract in nature. Okay, if you are making a relationship with an abstract class, you should fulfill one condition. What is the condition? You should override all these three methods. Okay? But you don't like to override. Since you are not overriding, it is it is showing something in red because you are not overriding it. We need to give the implementation for this, but you do not want to give the implementation. If you have such requirements, what you can do actually, you can change this class to what? Abstract. When you do this, error gone, no issues. When you don't like to override the abstract methods, you can do this. This subclass, again you can take class C, and this class C can do what? This class C can extend to class B. Okay. Now class C is responsible to override the some unimplemented methods. Because all these methods are available to class B, it is not overridden. Now class C job is to override all these methods. Now class C says, even I don't like to override, give implementation for this abstract methods. What you can do? Take this as abstract. Error gone. Okay, and you can take another class D. This class D is extending to class C. Okay, now this class D responsibility is to give the implementation for this. Okay, the idea here is you can skip by making the by converting the class to abstract classes, but at least somewhere in the class hierarchy, somewhere in the multi-level inheritance hierarchy, at least one subclass needs to give implementation for the unimplemented classes. You cannot just leave like that. Okay, if you just leave like that, okay, if you just keep all these three classes as abstract classes, there is no use. You can do nothing with this. You cannot create object for class A, you cannot create object for class B because they are abstract in nature. You cannot create object for class C because they are abstract in nature. Okay, at least one class should be a non-abstract class in this hierarchy, so that that non-abstract class can be utilized to do what? It can be utilized, or it can be it can make use of the benefits of these abstract classes. Okay, let me take class D. So this class D is extending to class C. Okay, now it's the class D responsibility is to unimplement all the override all the abstract methods. This is auto generated. You do not have to worry about this. Okay, we have three abstract methods in the great grandparent class M1, M2, M3. The great grandchild has implemented all these three abstract methods. So overridden is done. Okay, it can give its own logic. So M1 overridden, M1 over M1. Okay, this is M2. Okay, and this is going to be what? This is going to be M3. There are no errors. Okay, create an object. You cannot create an object for the abstract class. What is the way? A obj equal to new D. Okay, obj dot M1, obj dot M2, obj dot M3. M1, M2, M3. So all these methods are getting executed. Okay, actually, you are executing these implemented methods. Executing these methods is not possible. That's why there is a restriction in creating an object for the abstract class. Okay, this is one of the ways. Like if you do not want to, for example, I just want to implement M1 and M2. I do not want to implement M3. What I can do, I can remove this. I can change this class to abstract class. Okay, by doing this, what has happened? You cannot create object for the class D. So it is breaking it. It is breaking it. Okay, because the class is D is abstract. Okay, you can take another class, class E extends D. Right now, this is responsible to give the implementation for that particular one unimplemented method. This M3. Is what M3. See how many classes we have? We have class A, class B, we have class C, we have class D, we have class C. Out of 5 classes, how many are abstract? Class A is abstract, class B is abstract, class C is abstract, class D is abstract, okay, and class E is non-abstract. Okay, one concrete class we have and the remaining classes are abstract classes. Okay, I cannot create object for, except for E, I cannot create object for, I cannot create for A, I cannot create for B, I cannot create for what? For C, I cannot create for D, I cannot create, I can create only for what? Only for E. Okay, see, that's why we are getting errors for this class. Why it is not possible? Why it is highlighting that you cannot able to create an object for this? Because A is abstract, Okay, B is also abstract, C is also abstract, D is also abstract, E is non-abstract. When E is non-abstract, okay, you can place a reference. You can place a reference variable of type E itself, or the reference type can be the abstract. It can be A, it can be B, it can be C, it can be D, it can be E itself. Okay, LHS side, you can keep the reference type, no issues. But in the RHS side, you should ensure that you are creating an object only for the concrete class, not the abstract class. Okay, this is possible. Are you getting the process of object creation? Okay, by using this reference variable obj, okay, I can access M3, I can access M2, I can access M1. Yes or no? Because they are overridden. Obj dot M3, okay, and obj dot M2, obj dot M3, M2, M1. Okay, let me change this to D. Okay, let me run this. M3, M2, M1. Let me change this to C. Let me run this. M3, M2, M1. Let me change this to why we are able to execute. I mean, why we are able to execute all the methods, because the object type is E. Object is created for class E. So this is E. E as M3 method as well, M2 method as well because of this extends keyword, and M1 method as well because of this extends keyword. A parent reference can be anything, but still you will be able to call all the methods in the inheritance hierarchy just by creating an object for the concrete class. Concrete class object creation. Right? What is the last point that we have? We can have final methods also. For example, okay, I can have a method like M1 in the abstract class. Not M1, M4. Let me take M4 because M1 is already there now. M4. I can change this method to final one. If I do final method, if I keep final method, what does it really mean? I cannot override this method. Final methods cannot be overridden. That is what the point says. You can have final methods also. You can have static methods in the abstract classes. What does it mean? Instead of final, you can take static. There will be no issues. Okay, guys. So I have placed the static method. Let me remove all this. Let us see, are we able to call this static? Now see. Let me remove all this. I have an abstract class, abstract method, and inside this abstract class I have a static method. We cannot create object. I cannot do this, right? New A is not possible. New A is possible, not possible because of this. Can I do this? A dot M4. See this? Because static methods can be executed just by using the class name. No need to create an object because they are stored in the method area. So static method, to execute the static method, you do not have to create an object. Just use the class name. Even though the class name is abstract or non-abstract, no issues. Just use the class name dot the respective method name that gets executed. The problem is that the restriction is only when you create an object. You cannot do this. You cannot create an object for the abstract class. You will get an error. This is not possible. But we have an advantage by using the static methods. Okay, if you have a static method in an abstract class, without creating an object, you can call the static method a dot m4. Okay, so why m1 is printing here? It is m1. Don't get confused. That's why m1 is getting printed. M4. Because for calling the static methods, object creation is not mandatory. By using the class name, The class can be abstract in nature or non-abstract in nature. Okay, let me remove this abstract. No issues. You can call this method. If I remove this abstract, I will get an error. Why I will get an error? Because I have placed an abstract method. Let me remove this abstract method also. Even in the concrete method, the logic is same. You can just call the static method by using the class. So in the concrete method, I have two options, right? A obj equal to new a. I can create an object for the concrete class. Okay, I can create an object for the concrete class. By using this object reference, I can call the static method. So this is one of the ways. Second way is what? By using the class name, I can call the static method. There are two ways available in the concrete class, but the moment I change this to abstract, okay, this way is not possible. Why this way is not possible? You cannot create an object for the abstract class, but this way is possible. This is always possible. You are not creating an object. Since the method is static in nature, just use the class name to call this method. Right? You will get an output. Right? Is it mandatory to have an abstract method in the abstract class? No, it is not mandatory. It's not mandatory. Is it mandatory to keep the class as abstract when you have an abstract method? This is mandatory. Remember, okay, if I remove this, it is not mandatory to have at least one abstract method in an abstract class. It is not mandatory. It is not mandatory to have at least one abstract method in the abstract class. But when there is at least one abstract method, it is mandatory to keep the class as abstract. You're getting my point? You're getting an error. See? This is violation. If you have at least one method as an abstract in nature, definitely the name of the class type should also be what? Abstract. Mandatory. But when the class is abstract, it is not mandatory to have at least one abstract method. Okay, this is completely fine, guys. This part is completely okay. Why this is okay? Whenever the class is abstract in nature, it is not mandatory. It is not mandatory to have at least one abstract method. Either you can have abstract method or you cannot have abstract method. This one is completely valid. Okay, but when there is at least one abstract method, this one is not valid. Okay, when there is a class with at least one abstract method, okay, the class should also be abstract. The class should also be what? But this is not valid. How I can make it? How I can convert it to a valid one? Just by adding an abstract keyword just before the class. Add abstract. If I add abstract, then it becomes what? Valid one. Are you getting the differentiation? Right? And what is the last point that you can have variables in the abstract class? We have discussed it just now. Okay. So we can conclude that okay, the only difference between the abstract class and the ordinary class, you cannot create object for the abstract class, but in the concrete class you can create objects, right? And everything is found to be same, right? Except declaration part, and you cannot create an object. Apart from that, okay, don't you think that every thing is same? You can declare constructors in abstract class as well as concrete class. You can have final methods in abstract class as well as concrete class. You can have static methods in abstract class in the concrete class. You can have variables in the abstract class as well as in the concrete class. Apart from first these three, everything is remaining same, right? Are you getting this? Okay. By this, the concept of abstraction, the abstract class topic is over. Okay, this topic is necessary to understand what the interfaces in Java. What did I just say? To understand Java interfaces, okay, this abstraction Topic is necessary. Don't worry, we do not use much. I mean, Java abstraction is not utilized everywhere. Okay, but try to understand the implementation part and the declaration part, and try to remember these points. Try to remember these points. Okay, for the interview room, this is very important. But while developing the real-time application, we don't usually utilize much from these abstract classes. Okay, these points needs to be remembered. You should not forget this. All these points. Even if I wake you up at 4 a.m. in the morning, you should be in a position to list out these points. Okay. Next topic is very important. Interfaces are very important. Okay, to understand this, you must understand this. Okay, just the generalization things we are understanding. We are not understanding anything regarding the abstraction with respect to any Java applications. Just the control flow we are trying to understand just the control flow and the object creation process. Apart from that, we are not doing much about these abstract classes. Are we? Right? Tomorrow interfaces will be completed. It will not take much time. Okay, then I will start collections Java collections. Okay, very important in the interview. So after completing this Java collections, you can answer any Java